Welcome to this code scene demo where we're going to look at techniques for surviving the bus factor. The bus factor is one of those critical organizational metrics that you need to get right in any software project. For this demo, we're going to look at the Svelte codebase. Svelte is a JavaScript framework for open source development. To reason about the bus factor, we're going to look at the knowledge distribution factor. Code scene shows you a one-year trend of how the knowledge distribution has evolved in the Svelte codebase. Whenever there's a dip, you can click here and get an explanation as to why that dip in knowledge happens. In this case, we see that it's due to an activity, a developer offboarded. CodeScene tells us that back in May in 2023, two former contributors made their last contribution. That offboarding resulted in lower code familiarity. Code familiarity is one of those critical metrics that tells you how much of the code is written by the current development team. We see that for Svelte, this looks really good. So almost all of the code is written by currently active developers. That means that somewhere in the organization, someone has detailed knowledge of how every single piece of code works. This, of course, needs to be balanced with the other key metric here, which is knowledge islands. Knowledge islands measure how much of the code has key person dependencies, and we see that this aspect is risky in Svelte. A risky knowledge island metric puts you at risk for the bus factor. You might know the bus factor under different names. Maybe you know it as the truck factor or, my personal favorite, the lottery factor. But they all mean the same thing. The bus factor refers to how many people can leave before the code becomes unmaintainable because no one understands it anymore. We see here that in Svelte, the bus factor is very low. In fact, one developer has written 79% of the code. So, if we lose that one person, things are likely to become painful. Let's look at some strategies for handling this. The first one we do is to explore the bus factor. When exploring the bus factor, CodeScene uses the following visualization that you might recognize from our other visualizations. This one visualizes all the source code. The important thing here is the color, because you see most of the code here is blue. Blue is good because blue means that the majority of the code is written by the current team. So this is where you have strong code familiarity. We also see areas of gray, and these areas indicate code where you have lost knowledge. This is code written primarily by former contributors, people who are no longer around and no longer part of the development. So if you ever plan to do some work in these gray parts of the code, you need to plan additional time for learning, because that learning needs to happen. What's so interesting about this visualization is that it allows us to simulate the bus factor. And the way we do that is by looking to the right here, where there's a list of all main contributors to a codebase. What you can do now is simply tick the box next to a developer, and you will see the impact of that person leaving. When you do that, you can immediately say, okay, here's a very, very strong bus factor. If this person leaves, we will lose control of all the red code. That's a problem because it's 79% of the code, as we saw on the previous dashboard. So the question is, of course, how do you deal with this? There are a couple of things that work. The first is obviously to try to distribute tasks a little bit differently, so that other developers become familiar with this red code. But there's more to it. If you zoom in, you can see that CodeScene has marked certain modules with the dash border. And this dash border indicates that there's an increased and elevated offboarding risk. The way CodeScene determines offboarding risk is by combining these organizational metrics, the bus factor, with technical metrics like low code health. If there's a piece of code with a strong key person dependency and low code health, and that code is also a hotspot, meaning it's actively worked on, then we have an offboarding risk because it's very likely that this will be a high impact finding. So what do you do about this? One way to be proactive is to bring up the list of prioritized technical debt in the codebase, which is called hotspot code health. Let's look at that visualization. Here we see a list of modules that are at risk if the key person behind them leaves. To give you an example, we can look at template.js, which we see as unhealthy. It's red code. What's even worse is that we see that the code health has gone down over the past month. So this is now a bigger problem than it used to be. What I recommend in these situations is to improve the code health. We do that by planning a refactoring for it. However, there's a twist. If we improve the code health, we limit the impact of the bus. But if we do that improvement while pairing up the key person behind the code with another developer in the team, then we also improve our knowledge distribution and limit the impact of the bus factor. Thanks for watching.